Yes, good morning all. Now, in the last lecture, we had seen some of the properties of Z transform, right? Today, we'll try to do some of the numericals and then we'll go for the inverse Z transform. So, एक Z transform का numerical करते हैं. I'll write numerical. Find the Z transform. Find the Z transform of sampled RAM response, which is presented by the equation or given by the equation f of k is equal to k, where your k is varying in steps 0, 1, 2, 3, and it will keep on increasing. So this is your ramp signal. Okay, and now I'm talking about solution for this. To go for the solution, see, some of the things are just we'll revise. We already did this thing, right? We are trying to revise the thing. That is, differentiation property. Correct? What the differentiation property? What the property says? If you are saying z x of n is equal to xn, xz, z transform of this, then if you are multiplying this thing by n, then that is equal to minus z dz of xz. And we had seen. Now our number over here is not n, it is k, so I'll write k. So k x of k is equal to minus z dz of x of z. Right? We are going to use this. Now see, one more thing. This is one thing. And second thing that we are going to require for this is your Z transform of sampled step. Or sampled step, if you are having, right? Then how you can write that thing? We used to write it by gamma z is equal to z upon z minus 1. So these are the two things which we are going to use to solve this numerical. Now see, what you want to calculate is f of k, and which is k. So definitely I can write this thing as k multiplied by every time step input, right? That is a unit step input, that is 1. Okay, so in that case, now Z transform of f of k is Z transform of k into 1, right? That is Z transform of k. See, we are going for this. Now your function is x of k. So actually it will be k, right? This k, and Z transform of this, that is this one, and that is the what I can say, unit step. So what we can write for that? Now we want to write for this one, and we are putting in the formula. So minus z dz. I should not write k. Dz of, right? No, k into some function. This is k into 1, and this 1 is the unit step. So for that unit step, what I should write? Minus z dz of x of z. Now you know x of z. Your function, if I am saying x of k, x of z, your function is actually r of z. So you are supposed to write dz of, or I'll write gamma, and then in the next step I'll write this. Is it okay? Right? Now yes, now see. So that means Z transform of f of k is equal to minus z dz of this gamma function, right? which is equal to z upon z minus 1, and you want derivative of that. So minus z, right, and we'll keep this z as it is, and derivative of this is going to be z minus 1 minus z. Actually, I should write the reverse thing. Wait. It should be z minus 1 and z ka derivative, it is going to be 1 minus z as it is, and z minus 1 ka derivative 1 divided by z minus 1 bracket square. Is it okay? So what I can write now? Minus z, yes, z minus 1 minus z upon z minus 1 square. So you are going to have minus z minus 1 z minus 1 bracket square, and that is going to be equal to z upon z minus 1 bracket square. So whenever it will be a ramp input, z transform of that, you can very well write it as z upon z minus 1 bracket square. Okay, so one numerical related to z transform we have done. So on this line, yes, numericals can be asked in the paper. Alright, now the next thing is, we'll go for inverse z transform. How to get the inverse of, like Laplace inverse. See, when you are talking about Laplace transform from T domain, you are going in S domain. On the same line, when you are saying inverse Laplace from S domain, you are coming in T domain. Right? On the same line, when you are talking about Z transform now, you are going from time domain to Z domain, but your signal is discrete signal. Now, when you are talking about reverse thing, from your this thing Z transform, you are coming in time domain, but it will be in the discrete form. So you will have what we can say, instantaneous values for that particular or sample signal you are going to have. Instead of saying instantaneous value, you are going to have the sample signal. Okay, so I'll tell you the methods first, and then we'll go for one or two methods by which, yes, you can have inverse Z transform. Just a minute. Yeah. So see, in short, I'll write now 7th one, that is inverse of Z transform. Okay, so inverse of Z transform, when you are saying, see, in Laplace, एक थोड़ा सा description I am telling you. In Laplace transform, you go from T domain to S domain. When you are saying Laplace inverse, you are going from S domain to T domain, correct? Now, when you are saying Z transform, you had sampled signal. No doubt, you were in time domain only, but it was sampled in T, and you were there in Z. When you are saying inverse Z, what you should get is, from Z transform, you should go to sampled signal. You should get sampled signal, and definitely it is in the time domain. Okay, so I'll take one numerical based on that. Obtained. So before I'll go for the numerical, I would like to tell you there are two methods. Some more methods are also there, but simplest one are these two. That is long division and second one is partial fraction. Now partial fraction, well known, all of you are aware of it, right? So I'll write partial fraction. तो आपके लिए नया कुछ नहीं है. Only instead of S now you are in Z, nothing else. Okay, so I'm going for first method, that is long division, And instead of explaining you anything related to that, I would like to take numerical based on that, okay? Because that will be self-explanatory actually. So obtain inverse Z transform inverse Z transform of the function f of z is equal to z plus 1 z square plus 0.2 z plus 0.1. ठीक है, right? So we'll go by long division to solve this. Now long division means seeing whatever you have done or whatever you have learned in your I think third, fourth standard, right? For doing the division, same thing we are doing. So z square plus 0.2z plus 0.1 and z plus 1. So you want to divide this by this, okay? Now you are not having z, so, and this is z square, so you will multiply this thing by z raised to minus 1, so you are going to have z. So I'll write z, definitely we are going to do subtraction, then 0.2 and 0.1 z inverse. So you'll have this thing will get cut. It will be 1 minus 0.2, so 0.8 minus 0.1 z raised to minus 1. Okay, now again you are having 0.8 and z square, so you will multiply it by 0.8 z raised to minus 2. So when you do subtraction and multiplication of these two, you will have 0.8, right? One z is there, so plus 0.16 z raised to minus 1 and plus 0.08 z raised to minus 2. Yeah, correct. Okay, then if I'll do subtraction now, yeah, so I'll write minus, so this will get cut down, alright? So you are having minus, so minus 0.26 z raised to minus 1 and minus 0.008, sorry, 0.08 z raised to minus 2. Okay, so this is the remainder and this is your answer. Now you can go ahead for the steps. Now definitely if you are going for the next step, I will not do the thing, but very much clear that it is going to be 0.26 z raised to minus 3. Correct? And because it's minus, you know that you are going on the left hand side of the sequence. Because z transform whenever you are talking, right? And when you are going on the left hand side, it goes as z raised to minus 1, z raised to minus 2. We had seen in the definition of z transform, and that means inverse z transform for this you are going to have I'll write, because this is f of z, I'll write f of k now, f of k, which is having the sampled values as c. Now z raised to minus 1 है, तो z raised to 0 का term is not there, तो I'll write 0 z raised to 0. Correct? So the sequence will start at z raised to 0, that is your k का value is 0, then k का value is increasing, right? So if this is minus k, z raised to minus k, by definition, if you want, I'll write it over here. What you write? Summation of k equal to 0 to infinity x of k z raised to minus k. right? So when you are increasing this k, z is becoming negative. This is your xz. And I'm just comparing this sequence with this. You just see now x 0 when you are putting 0. So z raised to 0 is 1, right? But this thing is your k ka value actually 0. So what value you got over here? 0. But the second, when k is equal to 1, z raised to minus 1, z raised to minus 1, what is coefficient of this? 1. Correct. Then the third one, second one, z raised to minus 2. What is coefficient of this? 0.8 and minus 0.26. Correct. So this sequence will go ahead, and this is the inverse z transform of the given function. So I'll clear and we'll go for the second numerical and the second method for that, for finding out the inverse z transform. So I'm going for partial fraction expansion. Okay, so the question is obtain the inverse z transform of the function f of z is equal to z plus 1. Now what I want, whatever I have taken by partial fraction, you try to solve it by long division, right? Or reverse case also, and see whether you are getting the same answer or not. Z square. Definitely keep in your mind, uh, always the first term that is there in the sequence, you will find that sometimes you are having 0, sometimes some value is also there for it. But keep in your mind, whenever you are solving, even if you are getting some value for the first sampled sequence, first value, right? Even if you are getting some value, you put it 0 over there, because we talk about the systems which are initial conditions all equal to 0, right? And that's why first insert always keep it 0, and then you write the sequence. So z square plus 0.3z plus 0.02. Okay, so what we'll do is we'll multiply and divide by z. So instead of that, I'll write f of z by z, correct, is equal to z plus 1. Why I am doing this thing, you'll understand when we solve the numerical. Instead of explaining you the thing over here, right, you just observe, you'll come to know. So z, divide here, you will have two factors, 0.1 and 0.2, and you know what to be done now. A by z plus b by z plus 1 z plus 0.1 and c by z plus 0.2. Okay, so I would like to get these values. So z plus 1 is equal to a into bracket multiplication of these two, that is this function, z square plus 0.3 z plus 0.02 plus bz z plus 0.2 and plus cz z plus 0.1. Clear, right? So you'll write z plus 1 is equal to, पहले स्क्वायर वाले टर्म्स लिखते हैं, तो a plus b plus c inside the bracket z square. Okay, then z वाले टर्म्स, so 0.3 a plus 0.2 b plus 0.1 c inside the bracket, and this is z, and constant is only one, that is 0.02 a. Alright, okay. So now we'll equate the coefficients for z and constant. So let me write that thing on this side. Yeah. So see, 1 is equal to 0.02 a. Okay. Then z is equal to, z means z का coefficient, that is again 1. 1 is equal to, you are going to have z का coefficient, that is 0.3a plus 0.2b plus 0.1c. And one more thing, yes, a plus b plus c is equal to 0. Okay, so what you got for a? For a you got 1 upon 0.02, that is equal to 50. That means I can write a is equal to 50. Let me make bracket for it. And now we'll substitute these values in the remaining equation, right? So you are having a plus b plus c is equal to 0. So a is 50, that means b plus c is equal to minus 50. And what we'll do is I'll multiply this whole equation by 10. So you will have 3a plus 2b plus c is equal to 10, and this is now 150. So it will be 2b plus c is equal to 10 minus 150. So it is going to be 140. So 2b plus c. Correct? Just a minute. Now you solve this. So you will get the value for c as b as 40. See, b plus c is equal to minus 50, and 2b plus c is equal to 140. Can grab what I am writing? 140. Okay, so when you do this subtraction, minus, right? So these two things will get cancelled, but I think I made mistake. I should write 140. So this is minus, so this will become plus rather. Yeah, now it will be correct. Minus b is equal to 90. Is it correct? Still I made a mistake. Wait, I'll write it again. See, yes, I'll write 10. Okay, a ka value 50, so 150 going on that side. So 2b plus c is equal to minus 140. Am I right? Yes, 2b. And I made a mistake over here, I think. No, it's correct. Okay, it's correct. The thing was correct, right? Then 2b plus c is equal to minus 140. See, whatever I am having in the notebook now, over here I have written c, and for this I have interchanged the positions, and that's why I got confused why I am not getting the same answer. Fine, but I think I now will get. So minus and plus. So minus b is equal to 90. So b is equal to minus 90. So I'll make bracket for this, and b plus c is equal to minus 50. So c is equal to minus 50 plus 90, and you will get c is equal to 40. Yeah, I got third value also. Right? So the function now you can write this function you can write it as f of z by z is equal to a का value 50 upon z plus b का value minus 90 upon z plus 0.1, c का value 40 upon z plus 0.2. Okay, so when you multiply by this z, you will get f of z is equal to 50 minus 90 z upon z 0.1 plus 40 z upon will be better z upon z plus 0.2. And now we know, if you are getting this function, right, now how to write it in the reverse format, right? Z upon z plus 0.2. So you know that f of z, if you recollect in the exponential thing, we had written all these things. So nothing with this, you can write 50 delta k, because we want to write it in terms of sequence, है then plus 40, I'll write this thing first, plus 40, okay, minus 0.2 raised to k, correct, and minus 90.1 raised to k. Which formula we have used? We have used the exponential expression ka formula, if you can recollect, right? What we had, f of k is equal to a raised to k, right? Then we had derived this f of z. If you just go back for the previous video, you will find I have given z transform of this, and which is coming out to be z upon z minus a. So you got the same format. When we'll revert back, it will be a raised to k. Constant है तो constant will remain as it is. Constant में कोई change नहीं है. तो because it's 0.2, it is minus 0.2, and because it is 0.1, I should write minus 0.1. Yeah. Okay. So this is the formula which we have used over there, and we got the sequence. Again, I'm telling you, first term, right, normally is considered as, even if you'll keep answer like this, no problem, but even if you'll write 0 plus some values, then also it is fine, right? So this is for k greater than or equal to 0, and it will be equal to 0 for k less than 0. That's why. Okay, that's why the first point we used to take 0. Even if you'll write this, no problem. And now I want you to solve for when I finish with this lecture, right, I'm giving you one numerical. Please try to solve on your own. Okay, just a minute. Yeah, so find inverse z transform. Find inverse z transform of the function f of z is equal to z upon z plus 0.1, z plus 0.2, and z plus 0.3. I want you to do on your own. Okay, so we have done both the methods which are used for this thing, z transform, right, inverse z transform. Then the next very important thing, जैसे आप in the time domain when you are writing, we used to write the signal as differential equation. But whenever you will be in whenever your signal will be discrete one, you are not going to have differential equation, then it becomes difference equation because you are not having continuous signal. So you cannot write it in terms of t, but you have to write it in terms of samples, right? And then how to solve that equation using z transform, we are going to see that thing. Okay, so let me save this. I'll clear. Yeah. And now I think the point was seventh one for inverse Z transform. Now eighth one, that is difference equation. Yeah. Now how to go from differential equation to difference equation. First I would like to tell you that, and then we'll see the application of Z transform for solving the difference equation, right? So let differential equation, I'm just taking one example, right? B 2 d2x by dt square plus 3 dx by dt plus 2x is equal to y of t. Okay. Now I want to write difference equation, equivalent difference equation for this. So if I am talking about dx by dt and the thing is not continuous with me, I am handling two samples. So you know dx by dt means derivative, right? So the present instance, right, minus the next instance value of that and divided by the sampling time that is there will give you the slope. जैसे बोलते हैं ना, on the same line two instances, right? You are not having the continuous thing, but you are having the sample value. So these two values divided by the time period will give you dx by dt, right? On the same line, when you are having d2x by dt square, I should not write actually equal to, I should write approximately equal to this one. Now derivative of this again, right? So how I can write xn minus xn minus 1 up, wait, upon t minus the next instance difference that you are having, that means x n minus 1 minus n minus 2 upon t. So actually this will be first order derivative and again derivative of that. That means the whole thing divided by t. Now difference in these two instances divided by t. Correct? So if you try to solve this, you are going to have x n minus 2x n minus 1 plus x n minus 2 upon t square. Right? So if I substitute in the differential equation now, this differential equation, what I'll get? 2 xn minus 2 x n minus 1 plus x n minus 2 whole thing upon t square right, this is second order plus 3 xn first order now minus x n minus 1 upon t okay plus 2x, therefore 2xn, right, plus 2xn, whatever sequence that you are having will be equal to yn. Now on this side also you may have some differential equation. Just to keep the thing simpler, I have written only this thing, only y of t on this side. You may have second order, third order differential equation on this side. Now you see, if I am trying to simplify this, I will not simplify, but if you will try to simplify and want to generalize this, because our interest is to generalize this thing, then you will find that xn term, right, if you'll equate all these things t and all, or some value of t you are having, so your xn will have some coefficient, your xn minus will have some coefficient, your xn minus 2 will have some coefficient, right? So how I can write that then? If I'm saying that is b naught, b1 b2, so I can write b naught xn plus b1 xn plus 1, sorry, n minus 1 plus b2 x n minus 2, correct? And we'll go till bm, let us say x n minus m is equal to, now why I have taken only one term, but again that also you can generalize. So you'll have y naught yn, a naught yn plus a1 y n minus 1 plus a2 y n minus 2, and will continue till an y n minus n. Okay, so now when you are generalizing the thing and you will write in the what I can say, transfer function format, then you will have y of z by x of z, correct? Then or instead of writing it directly, I'll write it first in the z transform and then we'll go for. So what I can write now, if I'm taking after, I'll write after taking z transform. Yeah, so I can write for first term, so it is going to be b naught xz, correct? Then b1, now it is shifted by 1 on the left hand side, so z raised to minus 1, we are using the property, right? X of z, now here it is shifted by 2 instances, right? So z raised to minus 2, b2 z raised to minus 2 xz will continue till this one, so bn z raised to minus n xz is equal to, now I am writing for right hand side, so it will be a naught yz a1 z raised to minus 1 yz, right? Then plus a2 z raised to minus 2 yz, and will continue till an. Yeah, I should make an capital over here. An y of n minus n, right? So a n z raised to minus n y of z. Correct? So if we'll take x of z common, you are going to have b naught plus b1 z raised to minus 1 plus b2 z raised to minus 2 plus bn z raised to minus m. ठीक है, is equal to y of z a naught plus a1 z raised to minus 1 plus a2 z raised to minus 2 plus an z raised to minus n. Okay, so what I can have, y of z upon x of z is equal to a naught, let me see, yeah, so it will be b naught plus b1 z raised to minus 1. Now I will not write everything. bm z raised to minus m upon a naught plus a1 plus an z raised to minus n. Where is the cursor? Correct. So this is the format for, or I can write one more thing. So this can be written as g of z transfer function of the discrete system or discrete digital system that you are having, right? So this is the way, जैसे in your S domain, whatever was the differential equation, you are writing that thing into the S domain and you are writing the transfer function on the same line we did. Only the differential equation first we try to write it in difference equation and then we are over here. So we'll see one or two applications of this, so will be easy for us to understand this thing. So I'll write application of Z transform in solving difference equation. Okay, so we'll talk about the solution of a linear equation. So एक difference equation लेते हैं and we'll try to get solution of that. So I'll write given difference equation is y. So see, instead of this thing n, now here it is used k. Fine, है ना? That is just naming the sequence. Sometimes you'll find some of the books are saying n is equal to 0 to n equal to infinity. Some of the books are saying k equal to 0 to k equal to infinity. Starting may we have used this, but might be the numerical will be asked in this format. So you should be aware of both the things, right? While giving you the difference equation, I have given you it in form of n. Now the numerical is in form of k. Fine. So 0.5 y of k plus 1, correct, plus 0.06 y of k is equal to minus 0.5 raised to k plus 1. Okay, this is the difference equation which is given to you, and definitely what we want to find out, we want to find out solution. To find the solution means I'll write to find what it is. You are supposed to get y of k. Solution matlab y of k, right? For k greater than 0. Okay, so we'll try to express this thing, right? We are trying to take z transform of this. So you know k plus 2, it was minus 2, that's why it was z raised to minus, right? Now it is plus 2, so it will be z square y of z plus zero point 0.5 plus 1, so z raised to 1 y of z plus point naught 0.06 y of z, right? Plus sorry, is equal to, now I'll take this point minus sign and 0.5 raised to 1, so 0.5 out, and you are going to have 0.5 raised to k, so 0.5 raised to k, that means a raised to k, what we got, z upon z minus k, है ना, the z transform of this exponential term का. So now you are going to have into z upon z minus 0.5. Clear, right? So now if I'll take y of z common, so I'm going to have z square plus 0.5 z plus 0.06 is equal to minus 0.5 z upon z plus 0.5, sorry, z minus 0.5. Okay, now this term also will bring on this side, and we'll try to solve it by partial fractions. So we'll have answer for this, right? So I'll write y of z is equal to minus 0.5 z upon z plus minus 0.5, then factors of this, or should I divide it first? Z square plus 0.5 z plus 0.06. Okay, so I'll write minus 0.5 z upon z minus 0.5, and factors of this will be z plus 0.2, z plus 0.3. Okay, so now we want to do we want to go by partial fraction. So yeah, is equal to, I'll write a by z minus 0.5 plus b by z plus 0.2 plus c by z plus 0.3 and z. I'll take it out. So only for 0.5 you find out. Now you know why we are taking z out. After taking inverse, for that it becomes easy for us, right? And that's why keep this z aside and try to get the values of this a, b, c, so that it will be easy for us to take the inverse. Just a minute. Yeah, पावर चला गया. हाँ, so one sec. So I'll clear this. Yeah. Yeah. So now for this thing, for this expression, right, we'll solve this and we'll write minus 0.5 is equal to a into these two factors. So it will be z square plus 0.5z plus 0.06, right? Then for b, it will be z square minus 0.2 z minus 0.15, right? I am just multiplying these two things. I'll write that b properly. And then for c, it will be z square minus 0.3 z, okay, minus 0.1. Yes. So if we'll write, it will be a plus b plus c outside the bracket z square plus 0.5a minus 0.2 b minus 0.3 c outside the bracket z. And for constants, it will be plus 0.06 a minus 0.15 b minus 0.1 c, right? These are all constants, is equal to 0.5 minus. So you will have three equations: a plus b plus c is equal to 1, 0.5 a minus 0.2 b minus 0.3 c is equal to 0, and 0.06 a minus 0.15 b minus 0.1 c is equal to minus 0.5. Let me check I have written the correct thing or not. Yeah, correct. Yes. So if we'll solve now, I'll not solve those things because this is just simultaneous equation. You just put on in your calculator, or you may go for the this thing online. Right? You'll be able to get value of a, b, c. So I got a is equal to minus 0.893, b is equal to 7.143, and c is equal to minus 6.25. Okay, so what we got now? Y of z, if I substitute, right, we got, now by this z I multiply to every factor. So you are going to have a ka value minus 0.893 upon, just a minute. Yeah, z भी लिखती हूँ मैं, right? Z minus 0.5 plus b का value you got 7.143, z plus 0.2, and plus minus 6.25 z upon z plus 0.3. Okay, so what you can write for y of k? Now again we are going in the sample t domain, right? So I think very much understood whenever you are writing it in terms of the sequence, right, k or n, right, that is the difference equation, whatever we try to simplify. Okay, so y of z is equal to minus 0.893 minus 0.5, so it will be 0.5 raised to k plus 7.143, now minus 0.2 raised to k, and minus 6.25 minus 0.3 raised to k. So this is the answer for, yeah, let me save this, and in the next lecture we'll go for mapping, how to map z plane and s plane into z plane. What is the equivalence between these two? Okay, chalo, all the best. Thank you.